In today's video, we're going to install an AEM Water Methanol injection kit on my diesel pusher RV. If you've been watching my videos for any period of time, you know that my RV is significantly modified in ways that people don't normally modify an RV. But everything I've done so far has really gone a long ways towards improving the driving quality of it and has also made it more powerful, better fuel economy, and just more enjoyable all around. And this is really no different. The engine in my diesel pusher works hard, and rear radiator RVs are known for not having as good of cooling characteristics overall versus side radiator. Either way, neither is going to have things as easy as a standard front radiator mount like what you see in a pickup truck or some other RVs that have a front mount engine. And one of the things that I've always noticed on this RV is that the intake air temperatures run really pretty hot. Now, part of that has to do just with the fact that the engine is working hard, the turbocharger is always under boost. It's usually doing something in the range of 10 to 20 psi of boost going down the highway. Maximum boost is 30 psi, and if I'm doing a long uphill, I usually end up doing those at around 20 psi. Anything above that, the temperatures start to creep up too much. But my intake air temperatures are very typically somewhere in the range of 150 up to 170 or 180. Now, by itself on a diesel, this isn't necessarily too terrible of a thing, but one of the things that this also does, because the intercooler, or as is often referred to on larger vehicles, charge air cooler, that's in front of the radiator, and so one of the things that that does is that preheats the air before it goes through the radiator, making the radiator ultimately less effective. Like many RVs, especially rear radiator RVs, this one does tend to struggle a little bit with cooling. I have improved things significantly from when we first got it, and I've done a whole lot of modifications that I have a bunch of videos on, but I still would like to do something to help get the intake air temperatures down. Plus, I've never worked with water or methanol injection before, so this seemed like a good excuse. So, how does this work? Well, here's your normal setup. You've got an engine, the exhaust feeds the turbo then feeds air through an intercooler or charge air cooler, which is supposed to lower the temperature, and then it goes into the engine. Your turbo outlet temperatures can be very high. They can be up to the range of even 400 degrees Fahrenheit. For the purposes of this, let's say that this is around 300 F, and that's quite warm. After the intercooler, before it goes into the engine, like I was saying, it's common for me to say under load, let's say 170 F. So this air, again, as the cooling air is going through the intercooler, that cooling air gets heated, cools off the intake air, then it goes through the radiator. So adding water methanol injection is going to do a couple of things. It's going to reduce the intake air temperature, and it's going to do this essentially by absorbing heat, and then also that heat of the air, especially after the turbo, is going to boil both the water and the methanol. That is going to lower the intake air temperature. Methanol is also a fuel, so that's going to be adding fuel to the engine, which in turn is also going to increase horsepower. Methanol is a really interesting fuel for a couple of reasons. First one is it has a very low boiling point of about 150 degrees Fahrenheit. The second one is that it has a very high ignition point of around 750 degrees Fahrenheit. This is really good for us for two reasons. The first one is the low boiling point means that it will easily boil and take a lot of heat out of the induction air as it's doing so. People who run methanol injection in a heavy concentration report intake air temperatures actually below ambient because of this. I'm not going to be running 100% methanol. What I'm going to be doing is what a lot of folks do, which is using windshield washer fluid rated down to negative 20 Fahrenheit, and that ends up being around 30% methanol, the rest water. Water doesn't help quite as much as methanol, but with a boiling point of 212 degrees, it is still going to reduce the intake charge temperature significantly. Now, the way that the system works is you have a tank. The tank feeds a pump, and then the pump will feed the nozzles, which will go into the engine. AEM points out in their installation instructions that your nozzles are supposed to be after an intercooler, after an air filter, before a throttle body if there is one. I'm going to go against what they're recommending, and I'm going to explain why. What I'm going to do is, out of the pump, I'm going to inject the water methanol into the intake pipe after the turbocharger, before the charge air cooler. And I'm going to give it as much distance here as possible. My reason for this is because I want the air out of the turbocharger when it is at hottest temperature to come in contact with the water and methanol, boil those off, and have the resultant decrease in charge air temperature before it goes to the intercooler, and that will therefore reduce the temperature that the air is in the intercooler, reducing the temperature of the cooling air before it hits the radiator. That's going to help my radiator cooling slightly. And that is part of my goal for this. Now, why does AEM say that you need to put the nozzle after? You're going to have to ask them their specific reasons. But one issue that can occur, and this is probably the biggest one, is that if you are running a water or methanol injection before your intercooler and you're not running very high intake air temperatures, then that water and methanol can end up pooling in the bottom of your intercooler. And that you really don't want, for a couple of reasons. One, it's going to reduce the area that the air can go through and therefore get cooled. But the other thing is, if something happens and this water, let's say it builds up enough to get all the way up to the top here, you're going to get a big slug of water, and that can hydrolock your engine, and then at that point your engine's destroyed and you need a new one. I'm not going to be worried about that for this case. And the reason is because I'm not going to be running a very high concentration. My goal is not to get maximum horsepower like it is for most people who run a water methanol injection setup. And I'm only going to be running it under significant boost. I'm also specifically looking for this benefit to exist in a couple of noticeable areas, which are specifically when I'm doing longer uphill climbs with my RV. What's characteristic about this is that whenever I'm doing one of these long uphill climbs, I then have a good amount of driving afterwards, during which I'm going to have the system powered off and not injecting anything, which gives more than enough time for the heat from the engine to boil off anything that may have actually accumulated in the bottom of the intercooler, which I suspect is going to end up being about zero because of how hard this engine works and how hot the temperatures tend to be. So I just wanted to make the note, what I'm doing goes against the manual. I have my reasons for it. If you think that those reasons apply to you, then have at it, but understand that this is not what AEM recommends, and I'm not saying I recommend it for your application either. Disclaimer out of the way. So with that, let me show you where I'm going to mount things, and we'll get going. Inside the box, AEM sends you pretty much everything that you need. I don't have the water tank in here. I've already put that in the location where I'm going to mount it, and I'll get to that in a minute. But you have the water pump, the hose for the water. They include a hose for your boost reference to go to the controller, pre-made up wiring harness that has plenty of length of wire, and then you've also got your controller, which in my case, getting the diesel one, this has the big difference between the diesel and the gasoline one is that it has a higher range of boost pressures, since diesels tend to run a higher boost pressure. So I've already set this at 15 psi for the start and 30 psi for full pressure. I can play around with that however I want. And it has the fuse built in, so easy to mount. This right here is the boost reference port, so I will have to run a boost hose from here and then tee that into what I'm going to use is the wastegate boost hose. The kit also includes two nozzles. These use 1/8 inch NPT threads, so I'm going to have to put a 1/8 NPT bung where I'm going to mount these. The kit is supposed to come with 500 cc per minute restrictors or nozzles, whatever you want to call them, inside of here, and then also come with the 250 and the 1000 cc per minute ones. I did not have any additional ones in here. I have to open these up and determine which size is in here. My plan is only to run a single nozzle and run it at 250 cc's per minute right now, because for what I'm doing, I think that will be sufficient. So let's start mounting things. I'm now at the back of the bus on the driver's side, and like most RVs, this bay is utilized for your power connections when you're staying at an RV park. This is also right next to the turbocharger side of the engine, which is where I want the water injection to go. And because I don't really do much with this bay other than have the big long power cable and I have plenty of space, this is going to be a good place to put the water tank. Note that there's also a good drain here, so if this does leak, I don't need to worry about 5 gallons worth of windshield washer fluid or whatever I end up putting in there to be pooled up around here. You could argue that I shouldn't have this near these power setups, but I'm really not too worried about that. And this location will also work because there's enough height that I can still put a funnel in the filler and have enough room to be able to pour the fluid in. All I have to do is go through this wall here, and I'm in the engine compartment. So this is going to work out pretty well, I think. I have everything kind of mocked up in place roughly. I'm going to play a little bit with it some more, but basically I'm going to have the tank like this. I'm going to have the pump here. When you hook up the pump, make sure that you get the inlet and outlet sides correct. There's arrows on the bottom of it, so it makes it easy to determine. AEM also sells an inline filter that's supposed to go before the pump, and I'm going to use that because that seems like kind of a no-brainer to me. We'll start a little bit out of order with what I did up front. So because this is a rear engine bus, the controller really needs to be in the back. It could be in the front, but the biggest problem with that is that since there's the integrated boost sensor, I would have to run a very long boost hose for that, and it just makes more sense to put it in the back. So up front, I've got 2 things. First one here is the activate switch. This goes to positive 12 volts and then another wire that goes to the back of the bus. You'll see I have another switch. That's for some additional cooling fans that I put on the intercooler. Then over here is the indicator LED. This is optional, but I thought that it would be nice to put in because it'll tell me fault codes up front and then also give me an indication that the system is working when it is working. To get to the signals to the back, I have this shielded 5-in-1 wire, and I've used this before. It's really convenient for running these signals from the front of the bus to the back and vice versa, because that way you're only running one wire and you have multiples in there. I had actually run this for a previous project and I had 3 wires left over conveniently, so that let me have the activate power as well as the power and ground for the LED. So now we'll go to the back of the bus and see what we do back there. Now I'm in the back of the bus and I've got this kind of messy area that's one of the little hidden areas next to the engine compartment in the bedroom. And I have several other devices mounted in here for other things that I've added. It's really convenient because it's right next to the engine bay and you can put stuff that's out of the way. Inconvenient part is getting to it, but overall it's not a bad location. So what I've done here is I've mounted the controller up against this panel or this piece of wood, and I've got 2 wires that are just tied off that I'm not going to be using in this installation. Those are for a boost safe. Basically, if the system does not work, it'll dump your boost. I don't care about that. And another one is for a solenoid that will activate. You can activate it when it is running the system. So I don't care about either of those. You'll see 4 wires in the floor. Those wires are going into the bay where I've got the water tank and going to have the pump. Conveniently, this location is directly above there, so I just drilled a hole and ran them through. You can see here's the engine right next to that location. So I've already got several holes in the wall that where I'm running wires, and so I just drilled another hole, and I'm running the wires for that. Those are the 3 wires from up front, which you can see here. They go into that 5-in-1 wiring that goes from the front to the back, plus the power and the ground. I've attached the ground to the engine on the thermostat housing, and now I have to run the power. I'm going to make sure that this is going to a switched power, just because I don't want this thing to be powered on when the engine is off. I've got everything done here inside the bay for the water injection system. You can see that I've got the tank in and filled. I put it on top of some 2-inch thick pieces of wood to keep the outlet more or less in line or slightly above the pump inlet. I've got the tank bolted down with bolts that go through the wood and then through the floor bolted on the bottom, and then similar for the pump. The filter goes between the tank and the pump, and then the hose goes up and through, and then through that hole there it gets it into the engine bay. So now I've got the hose in a spot and I'm ready to go and test the system to see if everything looks like it works. They say to test it with water, but I'm going to plan for success here and assume that it all works correctly. I also already flushed the tank, which they say to do, and you definitely want to. There was a good amount of debris in there. One more thing I'll note is that the tank is listed at 5 gallons of fluid. I ended up putting about 4.5 in, and that was all that it took. So not too big of a difference. I couldn't find a good way to record the test, but if you look, you can see that there's some windshield washer fluid in this bottle. So to test the system, you need to have the power on, you need to have the plus 12 volts to energize the system as well, and then just have your hose going into some kind of container. Something to note is that when you push the test button, it will not just keep on running as long as you're holding it, and that's probably a good safeguard in case you're testing this when you've got everything hooked up and all. So I'm going to just leave this the way it is until I'm ready to install the pipe. I still am waiting on a bit so that I can drill and weld the hole in for the bung. So we'll do that and then we'll get it in. My unibit showed up, and so I got the bung welded in. Not my best welding work, but it is airtight, and I checked. To orient you, this is the turbo outlet side, which then goes down and then goes into the charge air cooler. So what I like about this position is that the nozzle will not be spraying into the turbo, it'll be spraying against the other wall of the pipe here, and so then should be getting a nice flow of hot air to atomize and boil the water methanol mixture. Hard to get good lighting in here, but you can see I've got the intake tube back in with the nozzle in and everything is hooked up. I've got a little heater hose that I've zip tied around a part of the frame because the hose was chafing and I didn't want it to eventually wear through, so that ought to help a little bit. So now time to close everything up and do a test drive. I'm now back home from about a 4,500 mile trip with my water methanol injection system on my RV. And on that trip it was very hot out. We had a lot of temperatures at or above 100 degrees. It was out west, so we had a whole lot of mountains that we were climbing, and we really got to put the system to the test. So a few observations. First off, yes, the system does absolutely work. I did find that I had to turn down the boost level where I was starting to get some sort of water injection, and then also, because I was running a smaller nozzle, turn down the boost pressure for maximum. I ended up starting the flow at about 5 psi and maxing it out by about 15 psi. If I put a larger nozzle in, which I may do at some point, I can change that upper bound to get more flow with more boost, and I think that that would probably overall help me. And that gets me into my second point, which is that while this does work, it uses actually quite a lot of fluid, and it doesn't last as long as I was hoping it would. I had hoped that with the 5-gallon tank that I should be able to go more or less between fill-ups without having to put in more water methanol mixture. And I didn't really find that to be the case. I found that it could in fact get used up much quicker. Part of this has to do with the fact that when you're driving a bus like this, especially when you're towing something heavy like we were, and you're going on these steep grades, you can be down going 25-30 miles an hour, and even if you've only got about a 30-mile section, that can be a full hour right there. So the end result was that I did have to fill the tank more often than I was expecting. The other problem with this is that water methanol mixed washer fluid that I was using is not available at all gas stations and in all states. Some states like California outright ban it. And even though I left here with a completely full tank and about another 5 or 6 gallons worth of fluid, and I was only using it on these uphills, at least at first, I found that I was ultimately I'd gone through it fairly early on into my trip, and I wasn't able to get more fluid, more of the windshield washer fluid that was a water methanol mixture very easily. So 5-gallon tank can work. It's kind of small. You do want to carry a whole bunch with you if you're going to do something like this. However, I also got to experiment quite a bit with water, just pure water, and I did find that that ended up actually still working pretty well. One thing to note is that with water methanol mixture, the methanol is providing some fuel. With the water, it's not. So probably the biggest difference that I noticed when I was running straight water versus water methanol is that with water methanol, I got a little bit more throttle response and a little bit less turbo lag, which was nice up in the mountains when it was very hot out. The straight water did a better job of lowering EGTs because it's just adding water and cooling things off a little bit, as opposed to cooling things off a little bit but then also adding fuel. I did not find that the water methanol mixture actually cooled EGTs on my setup at all. But what it definitely did was it definitely cooled the intake charge, regardless of what I had in the tank. The water obviously did not cool the intake charge quite as much, but I was seeing about a 30 to 40 degree drop in intake air temperatures, probably closer to 40. And with the water methanol mixture, I was seeing much more than that, probably closer to 80 or so. So it did work. It did absolutely make it so that I was able to more easily climb some of these steep mountains in this very hot weather. And it did also work to provide some throttle response. That said, it's a very marginal benefit. If I could do it, if I were to question whether I was going to do this over again, I would say I probably wouldn't bother doing it. But since I have the system in here now, I'm going to keep on using it. Maybe one side benefit that I will state is that the engine did feel like it was running smoother after I'd run a certain amount of fluid through it, maybe say 10 or 15 gallons worth. And I think that that probably had to do with getting essentially a steam clean on the intake tract. Even though this is an engine that is basically pre-emissions, there's no crankcase ventilation system, there's no EGR, there's nothing like that. But after 124,000 miles, I'm sure that there was some kind of buildup on the intake, and it's possible that this heated water methanol mixture, probably more so the water, helped to clean some of that off and make the engine run a little bit better. Did it improve fuel economy or anything like that? Not enough for me to notice, although I was running a heavier trailer than what I've run in the past. So all in all, I'd say that this is a success. It's not as much of a slam dunk or a major success as some of my other projects have been, but it is definitely nice to have out west, especially in the mountains, especially when it's hot out. The better throttle response was definitely a nice thing to have up in the mountains. And since I have the system installed in here, I'm gonna continue to keep the tank full. One thing I will probably change at some point is I'll probably get a bigger nozzle. I need to call AEM about that and see if they will send me one. The kit says it was supposed to come with it, so I'm assuming that that shouldn't be a problem. And otherwise, if I were to do this over again, or if you were to ask me if you should do it, I would say, do it if you want, but it's not going to be something that transforms your RV like some of the other projects that I've done. So hope you found this interesting. Thanks for watching.